station, steady state and step response results. Representing Team Goldschlager, we got Jason McCroskey. Stand up, Jason.
Let's go, guys.
There he is. Joshua Rogers. There we go. Kevin Brown. Woo. One clap for Gold Team. Awesome. Alright, today I'm going to show you the steady state and step response background for the voltage and the observed data, followed by the results, and finally the summary conclusions. Our input was between 85 and 100% because we luckily share our data with the lovely red team, blue team. Yeah. So our data is actually a little bit more smooth than this from what we've gathered because we don't have to do as big of a range. So, and our control variable is the voltage. Here is the schematic of our system. We have the voltage transmitter, which monitors the voltage that goes to the light bulbs. I'm sure you all have seen downstairs. And then that goes to the voltage controller, which tells it whether or not to raise the voltage or lower the voltage, and the action element is the one that does all that. So here is an example of our steady state response. This is actually for 80%, which isn't a data point that we use, but it looks beautiful. So here in the blue is the transient. It only takes maybe 2 seconds to get to steady state, and it's just smooth as a whistle. Steady state operating curve calculations. As you can see here, I have listed all of our results. Probably more than you can handle right now, but it's very nice. We used it to generate our steady state operating curve. Not quite as pretty as green team's. As you can see, we've got some hiccups as you go along. I can't quite explain them. We ran those tests at that input multiple times and kept getting something that was off of a linear line. So, here's an example of our step-up response. We did just 3% instead of like bigger ones that everybody else did, because again, we only have to do that smaller range. So we've got a 4% jump up, and then it's followed by our voltage output. And to calculate our dead time, time constant, and gain, we used this approach here. To find the gain, we did the difference between where the red voltage began at the lower input to where it ended up here, divided by DC. And then to do T0, we did from 10 seconds here to roughly about this point here when it was equal to 0.2623 times delta C, which is this variable over here. Here's all of our results, which I conveniently compiled into the equations here. This one here is for the step up, and this one is for the step down. And that is it for the voltage team.